So today I'm going to show you how we can bound 10 degrees using 9.75 and 10.5 degrees. So we've already gone ahead and done some of the hard work, so this video isn't tremendously long. This video is already going to be long because of how much work goes into this. But we have the sine and cosine of 18, 15, 30, and 60 degrees respectively. And what we're going to do is we're going to use those through a process to build our way down. Technically, I didn't need to do 30. I just like 30 because it has 1/2.
Sure. Okay.
So using the addition and subtraction theorems for sine, we're going to create different angles. So for instance, right here, we're going to do sine of 3 degrees first because that's one of the most crucial things for getting the lower bound. So right here, you have 15 or 18 minus 15, which gives you 3. And then from here, you can take 3, add it with 18, get 21. Divided by 2, you get 10.5. That's our upper bound. That makes it nice and simple. So 15 minus 3, 12. And then 12 minus 3 is 9. And what you're going to do is you take that 10.5, you're going to add it with 9. You'll get almost 20, so you're getting pretty close. And so you'll boost this, and you'll get it from 9 all the way to 9.75. And we'll bound them together using that.
Nice. All right, so here we go. Sine of 3 degrees.
sine of 10.5. Wow. In exact form.
Wow. I feel so good being alive right now. You know, this is so beautiful.
Do you think I can fit it on one line?
For the delta 13?
No, for this rewrite this but nicer.
I think this is good. I think this is good. I don't think I want to edit this video. I just want to upload like a raw video so that people can see your actual hard work for that.
Oh man.
I feel so fortunate of seeing this like in live action too, man.
That's crazy.
I've never seen that in live action, you know. I always thought that just some website that just like, you know, have some computer program and type this out
Oh
and
my
that.
god.
See this one? This one's gonna be way longer because I gotta go from 13 back.
Also, you know what's funny? Because I just went to a math talk about PDEs, and that just reminds me of a bunch of Laplacians.
Oh,
Yeah, 13 Laplacians.
So I did this, which is 10.5. Now I gotta do 9.75.
So let's take a look right here. So we have to go back from delta 13 and then blah 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 back to delta 1, right? We need delta 1.
Yes.
Oh my god. Alright. All yours. Come on, let's go. Man, you look shocked.
Whoa!
Okay, so we gotta get at least just simple for what's delta 13. It's just so it's like doing U substitution 80 times.
Basically, right? Oh, I see. It's like recursive, and you.
I have to keep putting them back in and
Oh
in
my
and in and
God.
in. So kind of like right here. So we know what sine is. So not to save us the trouble, we did just the simple formula for cosine from sine. Okay, so using delta 13.
All right.
I'm here all night, so.
This will be my opus. Okay, and so 12, which is this. Well, the good thing is at least when I got down to here, there were so many of the deltas I could just keep going.
Right.
You know what's kind of funny? When I hit delta 11 right here,
Yeah.
this is sine of 10.5 degrees.
Oh my god.
Oh my god, that's the one.
That's the one that just took 2 lines.
Then we need to
How about when we have delta 5, I just keep it as delta 5.
delta 5. I think that's fair enough. Yeah. Then just tell the viewers to go back to the video. You know, just rewatch that part. Yeah. Delta 5 I think is fair to just write it as delta 5.
Minus 5, 1, minus. This is kind of like, sorry, I'm going to butcher his name, but is it Fematica?
Fermatica.
Monica.
Yeah.
When he did the square or cube root of tangent. When he
Oh, when he was checking my derivatives, yeah. When he was checking my answer for the root, yeah.
that was a very long video.
One day a video computing pi. Like 7 digits multiplications by using the Ramanujan formula when n is equal to 1.
That's crazy.
See, this is a bit more how I write. Just walking all the way back across the floor. Okay. So now what I got left? I got 1, 2, and 6. 1, 2, and 6.
Holy cow.
Well, the good thing is 1 and 2 are simple.
You know, I'm wondering, have I ever seen an expression this big before in my life? Like actually written.
Oh, like actually drawn out, not typed?
Yeah.
Well, I guess you're welcome. You're welcome to Chesternomics.
Yeah, and then like this is not it yet.
Because we got to get to the 2, or actually 6. We got to do 6 first because 6 gives 2 and 1, and 2 gives 1.
Oh man.
Yes.
Brian, have you ever seen this something like this?
Oh my god, what happened? I was like zoning out for a second. It's on.
You got zoned out by his ASMR.
Reminds me of this joke where someone put this big square root, and then like at the end, just it became so big, someone just.
Oh yeah, yeah, I remember that.
Okay. Not gonna rewrite that again up here. Or you know what? Actually, I'm just gonna start from up here again and not move it.
Right, you don't have to rewrite that. Yeah. Just plug in the delta. No, not 5. Delta 2, delta 6, and all that. That's. Do you also want to plug in delta 1? I think you can plug in. Oh no, you have to plug in delta 6
if
first.
you do delta 6, how about this? I do delta 6 and then I leave 2 and 1. Because that's gonna be really
I think
long.
that's fair.
Okay, I'm gonna do delta 6, so one more line.
Okay, I think that will be fair. Yeah. Let's take a look right
I'm
here.
gonna make a big boy.
Oh my god! What did you just do?
Oh my god.
Okay. Okay, and then delta 5 is 1 minus delta 6 is. Ugh. I need to make this smaller. I feel like I'm wearing Crocs when I use this.
They're really good at erasing.
It is really
Yeah.
good.
By the way, Chester, how many hours per day do you do math?
I don't do it during most of the day. I do it before I go to bed. So from the hours of like 9 p.m. to probably like 2 a.m. So
9 to 5.
9 to 2.
I mean 9 to 2. 5 hours.
Yeah.
That's what I was thinking. Wow.
Well, the thing is, at the same time, because you have a laptop,
Uh-huh.
I multitask between. I have a game that I like to play at the same time I do math because it's a hard game.
You can play and do math. Wow.
I'm a nerd. I celebrated it.
No, you're Goku though, so you're good.
I knock it out of the park.
Well, I'll let you finish that first.
So it's not all that boring. I mean, I do get to do some fun stuff.
Mm-hmm.
This is probably gonna take 2 lines. Okay. This one 4, delta 2.
No, it's just that based on the things that you have shown me so far today, I know that you know a lot and you must be practicing math a lot.
It's more so there are questions that come up that just intrigue me.
I see.
And I like to solve them.
Right. I see.
Oh, okay. Of course there's a delta 6 there. Okay, delta 6 is this. Watch, you're gonna get a total niche group, and they're just gonna be like, give us more. Okay.
Have you ever written down sine of 1 degree in your radicals? The exact form of sine of 1 degree. Sine of 1 degree.
My friend did sine of 2 degrees once.
Oh, okay.
He didn't want to go one step further. We spent, I think, a month doing it because
Oh my God.
because the thing of what we did for this, because it's in the cubic computation, it's just so long.
Yeah.
Like this is maybe a 20th of it. It's really long. Okay, oh great. delta 1, that, close parenthesis, 2, and then that's closed, so it's this. Yep. And then still gonna go, so this is just gonna be and I'm starting from right here. This is where
Wow. Okay.
this is gonna be I feel like that was a bad move. We should start back to the back. Plus delta 2 4 delta 2 minus 5 8 1. Okay, and then minus 1 square root 1 minus 4 times delta 2 minus so many.
Whoa.
That's squared, and that's inside that, and then that stops there, and then I'm going to multiply it by that. Squared. Squared. And then it's going to have the two big lines from up there. And then this is all over 2.
Whoa. Everything inside, I believe, right?
Yeah, all of that on top.
Don't erase.
Well, I kind of can't.
Okay, that's yeah. Well, just getting. I want to get a good thumbnail. Yeah, like this. So maybe over there. Then maybe over there that part, the one you erase. So this part. Whoa! What did you just do, Chester? Whoa!
I just blew up the earth.
Totally. Wow.
I accomplished what Frieza couldn't.
We keep going? Do we keep going with any of that?
I don't think I have the space.
Wow. Okay.
Because like delta 1 itself is at smallest, it's 1, 2, 3, 4. Okay, so it's roughly like was that? I stepped over 4 times, right?
Yeah.
So it's roughly just delta 1 writing itself out is 1/5 of the screen.
Uh-huh.
And so I have 1, 2, 3 delta 1s, and delta 2 has delta 1 inside of it, so I have 3, 4. So I need a whole nother line.
Pam.
Yeah.
Can we get another whiteboard?
Another one?
Yeah, another whiteboard.
Oh, you really want me to do it?
Yeah, this one on the 3rd floor.
I'm good. I surrender.
Wow. So let's summarize. So what we just found is that sine of 10 degrees is in between of delta 13, which is sine of 9.75 degrees.
Mm-hmm.
And it has an upper bound of delta 5, which is sine of 10.5 degrees. And if you guys want to see the expression, this is the expression for sine of 10.5 degrees.
No, this is 9.75.
Oh yeah, this is 9.75.
And this is it's still missing a whole nother line.
Exactly.
Yeah.
So the small... the wooden, okay.
And the best part is, it still has delta 5 in it.
Yeah, that's the one that we wrote about like 20 minutes ago.
And let's see how many. There's 1.
Uh-huh.
There's 1, 2. I think there's 2 of them.
Yeah.
There's 2 of them. So at most, we're missing 3 lines.
Wow.
Yeah.
You can even... This is the time that you can even just...
Wait, you can even.
Yeah. Wow.
So what if you want like 10.25? Would you have a worse formula?
Yes. So the further and further you get down, like if I were to write this as signs of whatever and write them in there, it would be way easier and there wouldn't be all this hodgepodge.
Right.
Like, I remember when I wrote out how to get the sine of 13 degrees, it's just 5, 18, 3, and then we have 30. We can make this 21. Get that, it's 10.5.
Yeah.
12, 9.
Yeah.
Here, take those, give that. Just make it more formal. Okay. and then add those. 19.5, 9.75. Okay, so now the story becomes, how close do you want to go? Because you can add this with it, and you get, let's see, is that 20.25? Is that what that is? 20? Because it's 19.
20.25, yes.
Yeah, 20.25. And then you can divide that. And you get, this is where I was talking about the 10.125.
I see.
Oh my god.
And you can take this and you get 19.885. And you can divide that by 2 and you get 9. You know what that is?
7 something.
Yeah.
No,
So you get
I'm still.
increment-
Oh my god! I'm still looking at this and whoa! Oh my god!
Yeah.
I know what title should be already. You can even. By Chester. That's a perfect title for this
Just
video.
do it, just do
yeah. Let's say bye to the. Let's end this video. Just
Wait. Take out your phone and tell me what 19.885 is divided by 2.
Okay.
And then I can tell you how incrementally small that got.
Okay.
19.85, 9.9425.
So there you go. So if you want to do all that 5 more times, you can get this. You can get 9.9425 and 10.125. Right now, we're currently at 9.75 and 10.5.
Wow.
Oh my god.
I like the complex way much better. Of course.
That's why I like abstract math. You don't have those things. yeah.
But hey, you want to know what's the best part?
Uh-huh.
Remember, we can write it using factorials.
Oh yeah.
That's true.
Yeah, it was like 5 minutes only. What does that mean?
It just with explaining.
Oh that. Yeah.
But the whole entire thing, just boom.
Nice. Now let's end this video. Just say something to end this video or something.
You can't even.
Nice.
Okay,
All right.
Thank you, Black and Red Pen, for having me on. This was a great journey. Thank you.
Wow. Thank you for showing us all this. I have never seen an expression this big in my life, to be honest. Like, seriously.
It's still compressed.
Yeah. Wow.
It's insane.
What do you
Yeah.
think, Pan?
It's insane.
Yes, right? Yeah. How did you feel when you walked into the door earlier? When you walked into the office earlier?
I wasn't sure if you were filming or
I
not.
was.
And I was really shocked.
Okay. You got shot by all
We
this.
like stopped and we were like waiting for you to like.
Bless you. Bless you.
We were like waiting for you to take your head up.
Bless you. Oh my god, all the math. All the math.
Too much math.
It's this plant giving me allergies. Or this one.
The big one, the big one. Wow. Alright. So, alright. Thank you.
You're welcome.